Well, welcome everyone. Thank you for joining our webinar today. We have Lisa Sullivan with us. She is the author of Essentials of Biostatistics in Public Health, and she's a professor of biostatistics at Boston University School of Public Health. And Lisa is going to be speaking to us today about how to get your students engaged in biostatistics. My name is Sophie Teague, and I'm the Senior Marketing Manager for Public Health and Health Administration here at Jones & Bartlett. And if you're not familiar with Jones & Bartlett, we are a provider of instructional, assessment, and learning performance resources for the secondary, post-secondary, and professional markets. And we specialize in the areas of health and safety. So now let me introduce you to our featured presenter, Lisa Sullivan. Lisa Sullivan is a professor and former chair of the Department of Biostatistics at the Boston University School of Public Health. She's also the Associate Dean for Education. She teaches biostatistics for MPH students and lectures in biostatistical methods for clinical researchers. From 2003 to 2015, she was the principal investigator of the Summer Institute for Training in Biostatistics, which was designed to promote interest in the field of biostatistics and its many exciting career opportunities. Lisa is the recipient of numerous teaching awards, including the Norman Scotch Award and the prestigious Metcalf Award, both for excellence in teaching at Boston University. She's the 2008 recipient of the Associations for Schools of Public Health Pfizer Excellence in Teaching Award, and the 2011 recipient of the Outstanding Teaching Award from the American Statistical Association section on Teaching Statistics in the Health Sciences. In 2013, she won the Most Stellar Statistician of the Year Award presented by the Boston chapter of the American Statistical Association. Lisa is also a biostatistician on the Framingham Heart Study, working primarily on developing and disseminating cardiovascular risk functions. She's active in several large-scale epidemiological studies for adverse pregnancy outcomes. Her work has resulted in more than 200 peer-reviewed publications. And of course, she is also the author of Essentials of Biostatistics in Public Health, which has just published in a third edition, part of our Essential Public Health series. So with that, I will now hand things over to Lisa.
Okay. Well, welcome everybody. Thank you so much for joining the call. What I'd like to do is just launch right in. So this is the kind of thing that I would do starting off a class, and this is just an excerpt from a website. It was about a month ago now when I was putting these slides together, and it was timely, I guess, at that time. And it says, flu vaccine protects about half of the time, says the CDC. So this is the kind of thing I like to put up at the beginning of class, and you know, it's not the whole article, but here it says that the vaccine talks about the effectiveness of the vaccine that people are getting this year, and just about at the bottom of the screen it says this particular vaccine lowered the risk of having to go to the hospital or the emergency room by 48%, according to this team. So this is the kind of thing I might say to the students, did you get a flu shot? Would you advise people, why should someone get a flu shot? Why or why not, I guess. And you know, just try to get them thinking about what are the numbers behind these things, what do the statistics mean. So just taking that last sentence, if getting the flu shot reduces the risk that a person goes to hospital or the emergency room by about half, what does that actually mean? If the risk is 20% and that knocks it down to 10%, that may be important, but if the risk is 2% and now it's 1%, is that really a big deal? Again, just kind of presenting big picture examples, things that people see in the news to try to get them engaged. Just one more quick example, should food retailers post calorie counts on food? So this is where you go into Starbucks and you're deciding between the bagel and the piece of pound cake, and it tells you how many calories are on the foods. Is this something that should be done? Why or why not? And does it make a difference in terms of what people order if they can see this information? And then thinking about, you know, if we were behind this particular move or maybe not in favor of this move, how would we demonstrate whether it was worthwhile or not worthwhile? And here's another little citation that talks about tracking calories. If I'm just flashing this up quickly, but doesn't appear to change what people order when this information is available to them. The reason I post these kinds of things up in class is to just give students a feel that biostatistics is not just about sitting in front of your computer and crunching numbers. Of course, those of us who are biostatisticians might actually like doing that, but it's not all that we do. And trying to give students the idea that biostatistics is much more than statistical principles, but there's a context, there are nuances, there are always social, cultural, ethical issues that often are behind the numbers that we as biostatisticians get engaged in, and it's actually, I think, a piece that students aren't always aware of. So it's something that I try to bring into the class. So what I want to do today in our short time together is just go through some context, where we are in the field, maybe what faculty and students think coming into the course, just give a few suggestions for active learning, and then maybe give you some strategies and resources where you can find some of these things that, if you think they might be useful, bringing into your classes. So I always like telling students that the field of biostatistics is a phenomenal choice. Now, sometimes we get students in our classes who are taking it because they are forced to take this class, but I always take it as a challenge to try to get a few to commit to being biostatisticians, and this often helps. The Bureau of Labor Statistics estimates 14% growth for statisticians by the year 2020, and it's even higher for biostatisticians with growth in healthcare. Biostatistics is listed as one of CNN's top 100 jobs for growth, good pay, and satisfying work. And even if you don't want to major in biostatistics, we need to understand biostatistics to read the literature and understand what's being thrown at us every day just in the news. So what is our responsibility as faculty? Well, we're responsible for developing course content, what needs to be covered, why and how we do it. Ideally, that's linked to the outcomes that we're trying to achieve in a course, and hopefully related to the mission of the program in which our course sits, the vision and mission of the school. Well, here's how faculty often spend their time with students. A lot of the time lecturing, there's so much content that we have to go through. Maybe the students have some time for independent work in class. Maybe there's some time for student group work or other things, you know, guest lecturing or maybe a peer-to-peer exchange, something like that. Well, unfortunately, if you start at the bottom of this next slide, students only retain 5% of what they learn when they're listening to us lecture, which is, I apologize, what I'm doing to you right now. 10% what they learn when they've learned from reading, 20% from audiovisual, more when they see a demonstration, more when they're engaging in discussion, way more when they're practicing, and far more when they're teaching someone else. So we're probably not making the best use of that time with our students if we're doing a heck of a lot of lecturing. And for many, I don't know about many of you on the phone, I've been teaching this course for a long, long time, and the students have changed an awful lot over the last decade. They have varying abilities and comfort with quantitative material. That piece maybe hasn't changed so much. Often our classes are very heterogeneous. But our students aren't the type that will sit and digest and ponder a question. They want answers. And if they don't get it from you immediately, they're going to go try to find that answer quickly. They want things to be coming at them quickly. They want feedback. They want to know exactly what you're asking of them, why you're doing certain things. They are often very technologically advanced, but they are very interested in stories and the history and personal contact with material. Often hurried, I suppose we all are. They have a lot of pressure on them, the students that we're dealing with today, and so I do think telling them about the career outlooks for biostatisticians is very important. The thing that we have going for us is students do want to learn, so that's really good for us. This is probably goes without saying, but there's been a lot of research recently talking about broadcasting, lecturing is not the best way of engaging learners. Students need to be active participants to really make the most of the courses that we're teaching. So just on the student side, they want real-world knowledge and applications. They want to be able to use what they're learning in our classes. They want clear and organized presentations. They want to be stimulated. They want to be active and participatory in classes. this is a really important one. They want to know why each activity or reading or whatever it is you're doing in your course connects to their career. How is this going to be useful? They want us, of course, to be enthusiastic, helpful, and engaged, and I'm sure we all try our best to do that. They expect a certain level of service from us, and they want face-to-face contact, but, you know, we can often hold them back if we set reasonable boundaries and are clear about those things. So I guess some of the strategies for us, because the faculty and the students are kind of coming at this with different expectations, are to accept that there are differences between and among students and between students and faculty. Get the students involved in setting goals and expectations for the course, and I really try over and over again to tell students this is why we're doing this, this is how it fits into a bigger picture, because they often get lost sometimes in the weeds of what we're talking about. And, you know, just try to be flexible and not be surprised by things that happen in the classroom. When you open up a news article, such as the ones I just presented at the very beginning here, you know, people might launch into a philosophical discussion about some of those articles, and that's fine. You can take it as far as you can take it. So the way that we're promoting is student-centered learning, problem-based instruction, and really tying everything that we're doing to specific outcomes. So most of our courses are designed around competencies. What is it you want students to know and be able to do? And when you think of your course, designing your course that way, it leads you to writing learning objectives, which I think we all do, but then asking the questions for each learning objective, how will I teach this, and how will I know that they learned it? And it's really the second one that's very important, because that's what gets you to design assessments that will really tap into showing, being able to demonstrate that students can do the things that you feel are important. And as long as they're seeing all the learning objectives, then hopefully there's some understanding of why you're doing each thing that you're doing in the class. So in student-centered learning, we substitute active learning projects for lectures. So trying to explain the conceptual background of a particular topic and then stopping every few minutes and letting the students do something. Throwing out open-ended questions and problems. And you might think, well, biostatistics, is there really a lot of room for discussion? Well, there is when you let students think about the context, the social, the ethical issues around problems, and not just the calculations. That's the part, obviously, that's new to many of the students, and we want them to understand the appropriate use of statistical principles. But the part that's really interesting is, why is this result coming out the way it's coming out? What might explain it? And then, you know, where we can, using self-paced or team-based learning. So, of course, all this sounds maybe reasonable enough, but we have challenges because we have a lot of time pressures. We've got to keep up with our field, try to deal with students in our classrooms who's got varying levels. There's certainly a fear when you stop lecturing, and I've experienced this myself. You know, you sort of feel like, what's going to happen in this class if I stop talking? And then there's the fear that you won't get through everything if, you know, you don't continue lecturing at a steady pace. And then this, I'm not getting into too much here, but, you know, there's this whole idea of the flipped classroom, assigning things before the students come to class, and then there's the fear there, will they actually do it before they come? These ideas of group and team-based work are all sound good, but, you know, students need to know how to work in groups. There are challenges there, and they need some training on how to work with groups and teams. And then sometimes faculty are afraid if they stop the lecturing and control of the class in that way, that students might, you know, rank them poorly on student evaluations and course surveys and things like that. But, you know, I think that trying to intersperse a few active learning problems throughout a course really does help. So just a few strategies. One is to set the context. And this, by this I mean, tell the students what it is you're doing and why you're doing it. Continue to tie things together as you go through class. So I will often say in a class, here's what we did last time, this is what we're going to do today, and then this is what we're going to get into next week. Because it just helps them to stay connected to the bigger picture. Pre-assignments are very useful to try to get people interested in what you're going to discuss. You have to select them a little bit carefully because they don't have often too much knowledge to approach things, so just things that try to pique their interest. And then when you're in class, using realistic and relevant examples, giving students the chance to practice, this is the active learning piece, and provide some feedback. I don't know if anybody has used the audience response system. We call them clickers here. You can use these little clickers that are set up for this purpose, or sometimes you can use cell phones if you program them correctly. I'll show just some examples of that. And then the last thing is, in designing assessments, homework sets, problem sets, I think try in as far as you can to make these authentic. What I mean is, don't give students agricultural examples. Some of the old textbooks talk about old examples, and they're interesting from a historical perspective. Students want to be working on things that they think are real. And it doesn't mean that the data always have to be real, but realistic problems. It just, piques their interest a bit more. So in the textbook, we've added in this third edition a section that we call when and why. And before we get into any topic, whether it be descriptive statistics or confidence intervals, we try to pose a couple of provocative questions and bring up a timely, relevant example and get students thinking about that particular example without saying, and by the way, we're raising this because it's an example of how you would use confidence intervals. And then we throw out a couple of big questions that the instructor can then use, say, at the beginning of class to have students discuss, and then you can get into the technical aspects of the topic of the day. So here's an example. Here is a screenshot from the American Society of Addiction Medicine, just giving some statistics on opioid addiction, facts and figures. And of course, there's a picture of Prince that the students would recognize, and it's giving some statistics on the numbers of overdoses that happened in 2015 and the numbers that were related to heroin and so forth. And so you might give the students a few of these figures and then ask the question, is prescription drug use an issue in your school or community? How would you measure to the extent to which that might be going on? What are the challenges in collecting this kind of data? Obviously, it would be sensitive to collect this kind of information. To judge whether there might be a problem or an issue in your school or community, you'd need to compare that to something, and how could you ensure that you're comparing apples to apples? So these are the kinds of questions that you might raise at the beginning, and then you could get into what do you measure, what are the variables, how do you summarize them, and how do you make the comparisons. Again, this issue of authentic assessments, use real data where you can. Students really gravitate to this. They like practicing. They like to see the messiness of real data. So, and there are a lot of data sources out there that you just need to know where to go looking, and I'll show you a few examples. But let students ask questions of these data. And again, you might be focusing on teaching them how to do an analysis of variance, but bring in ethical, legal, all these other issues into the analysis and interpretation of the data. I've had the privilege to work on the Framingham Heart Study, which is a phenomenal study, started in 1948 with over 5,000 men and women enrolled in the town of Framingham, which is about 15 miles west of Boston. It's a large longitudinal cohort study. The original participants have been examined every 2 years for cardiovascular risk factors, and it started out as a study looking just at cardiovascular risk factors, but it's since broadened, and now it looks at basically every medical condition. In the mid-70s, another 5,000 of the children and their spouses were enrolled in what they call the offspring cohort. And then in 2002, a third generation was enrolled of about 4,000 people to start to look at genetic risk factors for cardiovascular disease. And much of what we know actually about cardiovascular disease in this country was actually discovered in the Framingham study. So our students know, take it as fact, that smoking increases the risk of heart disease. That was actually demonstrated for the first time with data from the Framingham study. So there are data that are available from this study that you can use in your classes. So one thing I also want to point out to you is there was a really nice documentary that was done by PBS talking about the hidden epidemic, heart disease in America. And you can actually get this video and you can show it. You don't need to show the whole thing, but it goes through why in the 1940s and 50s was this epidemic of heart disease. You know, prior to that, people only used the term epidemic to talk about infectious disease, and now all of a sudden they're talking about an epidemic of heart disease. There were some very interesting reasons why things were happening this way. And it's a really nice video that showcases some of the changes in society that led to this, you know, all of these events of cardiovascular disease happening. So you can show this video or a little clip of it for 10 minutes. There also is a fantastic teaching data set of about 4,000 participants. It actually has 11,600 person exams. What I mean by that is each person has up to 3 cycles of data in the data set. And what we've done is made these data sets available, and we've put together some integrative exercises that you can ask students to use to generate descriptive statistics on key risk factors, do some statistical tests, and it can go all the way, you know, as far as you want to take it, up through regression analysis. So the data sets are there. You can do the analyses in Excel or with whatever tool you happen to be using for your study. But we've made these data sets available and certainly hope people will use them. And there's a nice documentation of all that's available there. There's quite a lot that the students can play with. There are lots of other data sources where you can download data. Another is from the National Heart, Lung, and Blood. They have a data repository. The CDC has some really nice public use data sets that you can go pull down. The Global Health website has lots of data. And then there's the Data and Story Library that was put together some years ago that has lots of different data files that you can go pull, and maybe you could even ask students, you know, what particular questions are they interested in, and point them even just to the websites, and they could go search for data sources that might be available that would give them some insights into their questions. So another piece that's new in the book, this edition, is a new chapter on data visualization, and we've put this in because there's so much data out there. This statistic is sort of surprising, but it says 90% of all data in the world has been generated over the last 2.5 years. So we all know we're swimming in data. The issue is, what do you do with it? And we've all certainly seen evidence of bad data, bad information, ways that people present information that's not very clear. So we put in some ideas for techniques to produce good tables and figures to summarize data, trying to bring together all of this work that people are now doing on data visualization, but grounding it with solid principles of statistics. So that's also something new in this particular edition. And I just raised this example of getting students engaged in the class. For those of you who use the audience response system, or again, you can use cell phones. You can actually set up systems where you can capture responses from the student in the class, or even a show of hands is fine sometimes, depending on the kinds of questions. And you can pose questions that assess their understanding or misunderstanding of key concepts. And oftentimes what I'll try to do is put a question up, and then, you know, obviously you give the correct solution as one of the options, but try to put common misunderstandings as other options, because then students, I should have said this, respond anonymously, but if they see, wow, 30% of us missed that, I'm not the only one who missed that, gives you a chance to go back over a particular concept. So I'll just show you some examples, and these data are a little bit dated, but I just pulled them to give you an illustration. So these data come from the CDC. I downloaded them right from the CDC website, from their health and risk behavior survey, and there's a much more recent one of this. I just happen to have this. So I used this when I was doing a class with some high school students, and so this particular survey captures all kinds of data on risky behavior from high school students. So I asked the question, do you currently smoke cigarettes? And I used the audience response so they didn't have to identify when they were responding. And of course, some say yes and some say no. And as you collect the data, the histogram pops up on the screen and shows what students are saying. But then I showed some data, and in the survey itself, 18% of students smoked cigarettes, 46 had tried them in their lifetime, and 6 say they smoke daily. Well, all of a sudden people say, you know, those numbers I would suspect look a lot higher than what you just captured in the class, and the way these data were collected in this survey, it was by a self-administered survey. That's a little different than me asking them face-to-face in the classroom. Why wouldn't someone answer, you know, let's say honestly to that kind of question? And it allows you to talk about how do you ask survey questions? Are these questions best asked face-to-face, or should they be done in a self-administered survey or some other format? Have you ever had an alcoholic beverage in the past 30 days? Of course, they all say no. And then you say, well, almost half of the high school students said they had. 73% consumed alcohol in their lifetime, 20% before age 13. And it just gives them a feel for data, what these things look like. What do you make of these? Why would what we're collecting right now in this classroom look different than maybe what is being reported in these surveys? Do you eat breakfast every day? And then, you know, giving the figures of what people say. And here we might say, who cares? Who cares if someone eats breakfast every day? What's the importance of that? And then you could even get into, well, if someone has a good breakfast, they might be more prepared for school and able to concentrate. And of those who don't eat breakfast, is that their choice? Why would they not you know, have breakfast before they go to school? Is that something that's available to them? And just getting people to think about, why does someone answer yes or no to certain questions, and why are these important? How much television are you watching per day? And you get the data. And this is also asking, you know, are you physically active and so forth? And again, still asking the question, why do we care? Why is this stuff important? And trying to tie it to, when we do studies of health, we might ask these kinds of questions. These seem like simple little throwaway questions, but they might really help us to understand why someone develops disease later in life. And this is just a throwaway, but maybe just for fun. Are you right or left-handed? And then you can actually show what the correct answers are here. What % of the population are left-handed? After you pose the question, students can answer, and then you can click the slide again, and it will indicate the check mark. I just gave it to you right away, but you can, you know, phase that in. And then, which of the following people are left-handed? I threw this one out, and it turns out that all 3 of those were left-handed. But, you know, just kind of for fun with the students. So the bottom line of all of this is we want to set a tone in a classroom that supports learning, encourages different points of view. And again, biostatistics is not black and white, which is something for students to learn. They don't always appreciate that. And so always raising questions about, why did this come out this way? What does it mean? It's not just this is significant and this is not significant. What does that actually mean? And actually talking with students about your own biases. We all look at data and have our own interpretation, and that's because of our own opinions, and biases may seem like a strong word, but we all just have different ways of looking at things, and those are important to get students discussing. This is what biostatisticians do. We get engaged in data, we do the analysis, and people look to us to try to help them understand information, but it's not an easy task, and getting students to understand that biostatistics is much more than the numbers, I think, is a fun way to get them excited about the content. So I think I will stop there, and I hope I didn't go too quickly. I was just trying to leave lots of time for questions. So please feel free to pose a question.
Thank you so much, Lisa. Go ahead, Angel, if you'd like to repeat the instructions for how to voice your question, that'd be great.
Yes, ma'am. That's *1 if you would like to ask a question.
*1 if you want to voice your question. If you prefer to type your question, you can do that as well in the Q&A box or the chat box, and we actually do already have a few questions that have come through. We had a question here about, Lisa, that these are great suggestions for active learning. Are there suggestions that could be adapted to an online asynchronous course?
Yeah, so, you know, the active learning is really just stopping and pausing and letting the students practice something. So if you were to, you know, give a discussion about descriptive statistics, then maybe having a little exercise right then and there where students go and take some data, say this Framingham data or something else, calculate some summary statistics, and then ask them, in this particular analysis, does it make more sense to summarize a typical value with a mean or a median? Why or why not? And in that Framingham data, just as an example, you know, some of the laboratory values are extremely skewed, which is a really good example where students would calculate a mean, but that might not be the best measure of central tendency. So I think it's just, you know, trying to give some practice exercises that are with realistic examples interspersed through lectures as you cover material.
Great, thank you. Someone is asking, what textbook do you recommend?
Am I supposed
That's an easy one.
My own textbook? I think so. Yeah. Well, you know, and this came out of, I've been teaching this class for quite a long time, and so the material in this textbook came out of my own teaching and what I found myself putting together as resources to bring into the class. So, you know, I hope this has a lot of good examples and tries to use the techniques that I've talked about here. There are certainly many good books, but we happen to use this one here where I'm teaching now.
And by this, Lisa is referring to, just to repeat for anyone who may have missed the beginning, Lisa Sullivan is the author of Essentials of Biostatistics in Public Health, 3rd edition, which is part of the Essential Public Health series. Well, this slide will give information about that book, and I'll also send around information about how to request a review copy if it's something you'd like to consider adopting for your course. I have another question here. How do you frame your questions for in-class participation?
As open-ended as possible. So, yeah, I teach large classes usually, so, you know, just trying to get conversations going, and I try to almost make them as provocative as possible. Even the flu shot. Why should you get a flu shot? You know, why should I go through the pain and maybe the expense of getting a flu shot, you know? So just raising questions like that that are as provocative and open-ended as possible, because that's where, you know, oftentimes people will even start the conversation with, well, what are you talking about, kind of thing, and that's good. That gets the conversation going.
Great, thank you. And we do have a few more questions coming through on the Q&A box. How strong must students be in statistics to take the biostatistics class with your book? Are there certain prerequisites?
No. So this book we use here as for a first course in the Masters of Public Health. So it's a graduate level course, but there is no prerequisite for this program. We've also used this book for a first course in statistics, not even necessarily biostatistics, or biostat at the undergraduate level. So it's really meant to be a first course. There are no prerequisites to get before you get into this book. And
Great,
it's not,
excuse me, I'm sorry,
wasn't designed for math majors. It was really designed for the non-math majors who often have to take a statistics course for, you know, as a requirement.
Great, thank you, Lisa. How do you encourage students to read before the class?
So the pre-assignments that I was talking about, I saw some of them going. What I have done is, if we're talking, say, about say the topic is 2 sample t-tests, what I will often do then is find a clinical trial or something where the investigators randomize people to the treatment group or the placebo group, and the outcome is continuous, so that the primary analysis is a comparison of means using a t-test, and oftentimes it is in a clinical trial. So I find a publication, and assign them to read it. And these are short articles. I mean, not very lengthy, a couple of pages, but they're all, you know, medical studies that hopefully are on a topic of interest. Assign that to the students to read, and then ask them questions like, you know, who's being compared? What is it that the authors are trying to do here? And get them thinking that they've constructed two groups. And then what is the outcome? What is it that they're interested in? And really trying to get them through, how do you come to the thinking of doing a two-sample t-test? Well, you have two independent groups, you have a continuous outcome, and you're interested in comparing the means. So it's just trying to give them something that's interesting and relevant that includes the analysis that you're talking about without them really knowing that, and having them come to learn that it's, you know, what the setup is, what's the design, what are the, you know, the groups, what's the outcome, and no calculations, just what's the setup. And then you come to class, talk to them about, you know, how to do a two-sample t-test. Then you can even go back to the article. Now let's look at the data in Table 2, for example. How did they make this comparison once they've had a chance to try to digest the setup?
Great. Thank you so much. Let's see, here's a question about active learning techniques. Do you think the active learning techniques work as well in very large classes, or do they work better in smaller classes?
Well, I teach large classes, and what I mean is, I teach often, you know, there could be 100 people. This last semester I had 50, which I think is pretty small for me, but you know, I think it works perfectly fine in a reasonably sized class. And I just think that it helps students if you talk about something. I used to always, when I was teaching, I'd show them 2 or 3 examples. And that was just me. I wanted to make sure they really got it. Let me walk you through it a couple times. And I think that was, in retrospect, you know, I didn't need to do that. What I found that works way better is, let me show it to you once, and now let me give you one. And so I'll do one problem, and then I'll give them a problem, and let them struggle through it for 10 minutes. And that's all it takes, is stopping talking for 10 minutes. And it really makes a big difference. And then if they can't do it, that's fine too. And then you can go back and, you know, show them another one or work through it together. But it's really just stopping and having them do something for 10 minutes. And I find it works perfectly fine, even in moderate and large classes, and certainly in small.
Great. Here's a question. How much emphasis do you place on formulas, and do you use statistical software in class? So with the book, in the earlier versions, we focused on Excel. Of course, there's SAS and R and lots of other things that students can use. We chose Excel just for the accessibility of it, and put together a lot of materials, supporting materials in Excel. In class, we made a decision at our school to teach the students R. I personally don't use R that much in my work. I happen to use SAS, but we decided on R for the reason that it's free. And so that's the software that we use in class. But it works, the way I teach the material is not dependent on the software at all. You can teach this entire material without touching any, you know, software. We purposely put in the book examples that are small enough that they can be done by hand. I do pay attention to the formulas, and I know some people don't think it's realistic to have students calculate a standard deviation. I feel like you should do that one time with a reasonably small data set, because there's a lot of intuition to, you know, the formula and where it came from and what it means. And so I do like the students looking at some of the formulas. We certainly do not focus much on hand calculations once you get up to analysis of variance. I don't think that's necessary. But hopefully by then, students know how to calculate and are very comfortable with means and standard deviations and test statistics and get the gist of it, which I think is fine. Okay. There's a question here, which I'm not sure if the person asking the question is referring to an online course, but what advice can you give with regard to collaborative, cooperative learning when students are scattered all over the place?
Yeah, so I don't teach online, so I'm really not the expert in that area. But I think, again, any kind of problem, whether it's designed to be done individually or in a group where students are working together on analysis, I think that's great. So in our classes here, which granted are residential, but we certainly have challenges with students trying to get together, we have them work in teams on a project where we give them a data set, and an example might be this Framingham data. We have them come up with a question and design some analyses and have them write the equivalent of an abstract, you know, a one-pager, what did you do, what was your question, how did you approach the analysis, and put together 2 to 3 tables summarizing results. And they do that in a group, so that could be done physically sitting together or online discussing, you know, who's going to do this analysis and what is the question we're going to address. So I think it can be done. I really am not the expert on online by any means.
Great, thanks. Before I continue on with questions, Angel, can you tell me if we have any questions on the line?
And there are no audio questions, ma'am.
Okay. Here's another question, similar to a previous question about prerequisites. Should students be math majors for this class or biology majors?
No, neither one. So the courses that I have taught and used the approach that's in this book are for the non-math majors. So all comers, so they can be, you know, social science, psychology, anything, biology, fine, but they do not need to be math majors.
Great, and then I have another question about students. Is this for undergraduate or graduate students?
So it can be used for both. So the material that is in here actually came out of a lot of teaching at the undergraduate level. I happen to teach in the MPH program, but the MPH is maybe a unique graduate program in that it does not have prerequisites. So we use it as a first course in biostatistics at the graduate level, and it can be also used at the undergraduate level. I don't think you could get through the entire book, what we cover in the entire book, in a one-semester undergraduate. I guess it would depend on, you know, how deeply you wanted to go into things. At the graduate level, we certainly spend much more time on the interpretation and, you know, a bit more of the nuances of some of the analyses, but we use this for both levels at this point.
Great. Here's a question. Students keep asking what is the difference between biostatistics and statistics, or they ask, should I take biostatistics or statistics? How do you answer?
Well, I'm biased, I will say that. So biostatistics is the application of statistics in medical, public health, biological applications. So I happen to have a PhD in statistics, but my work is as a biostatistician. I gravitated towards biostatistics because I like the medical aspect of the applications. I find it interesting, and for many undergraduates, that's the piece that interests them. You know, underneath it all, the techniques are the same. So it really, you know, matters more what is the student's area of interest. If they have an interest in you know, the medical field or the health science field in any way, then I think biostatistics would be better. It's certainly viewed more favorably, I can tell you, if a student wants to go into a graduate program in public health. We always like to see that students have taken an undergraduate course in biostatistics. It's not a requirement by any means. If they've taken statistics, we're happy with that too, but I think if they're interested in public health, medicine, health science, then biostat would be the best way to go.
Great. Here's a question somewhat related. What modifications do you suggest making to your textbook to use with younger students, i.e. middle schoolers?
Well, I do think that I'm not sure that they, and I would need to be corrected. I don't teach those students, so I don't know that I'm the best person there. But just my guess, I think that they would like to do a lot with the descriptive data. I've actually gone into a couple of middle school classrooms just to talk to them about what is biostatistics, and what I did with them was I went to the CDC website, and the CDC has growth charts that you can download. And what I did was I downloaded the growth charts, and they're separate for boys and for girls. And there are charts there for infants, 0 to 3 months, but then for young people from age 2 to 20, I think, actually. And what you can do is you can print out different anthropometric measures. So what they show, the one I brought with me was head circumference by age. And I brought paper copies of these charts, and then I brought some tape measures with me, and I had the students measuring their head circumference of their neighbor and trying to figure out what percentile that student was. And then we just started talking about percentiles and what does it mean, but then got into, you know, what does it matter if you are in the 90th percentile or the 10th percentile? And that just kind of opened up a discussion of why do pediatricians use these measures? And they're trying to flag students who might be sick, you know, on the lower end, students who might have growth issues. Maybe there's nothing out of the ordinary if somebody is in the 95th percentile. But I think you can maybe just not go as far with some of this, but I do think that young people are interested in data. They see as much data as we do, I think, so understanding even some of the basics of descriptive data might be of interest to them. So that was just something I tried.
Okay, and someone is asking, can we show what the book looks like? So I've just flipped the slide here so we can see what that looks like. And of course, if you would like to request a copy, you can do that by going on our website to this link here. And there you just click the button for an instructor's review copy, and we'll get one out to you. You can also look at sample chapters and request access to instructor materials, as well as if you want to use Navigate 2, the book comes with Navigate 2, which is access to an online component with the entire ebook, chapter quizzes. There's also a manual statistical computing using Microsoft Excel. All those materials and access to review them are available on our website. We do have a few more questions. Let's see. Do you have some additional PBS videos that can complement your text like the Framingham study video? Also, any simulation-related videos or links?
Because the data that we use in the book is almost all using examples from Framingham, that's the only one that I know of. I can send out some links. I can make these available to Sophie. One of my colleagues has done a lot of work developing online modules for biostatistics with some of the material we have here, for epidemiology, that has videos for other examples. So I could try to collect some of those. I'm sorry, what was the second part of that one?
Any simulation-related videos or links?
Yeah, I haven't used simulation, though I know people do with some of the probability exercises. I might have to look up some of those. I could try to chase some of those down. I can't think off the, you know, right off the top, but I think I could find some.
That would be great. Thank you, Lisa, and I'd be happy to send that information out to everyone.
Okay.
Let's see, there was a quick question about, if you have them do a problem in class after presenting the material, how long do you give them to work on it?
Just 5 to 10 minutes, and that doesn't mean everybody gets it done. They don't, but it's okay. I mean, it obviously depends on the problem, but just 5 or 10 minutes makes a huge difference. They just try to get into something, and you know, if you set the problems up that are reasonable in length, you know, it just gives them a chance to try to practice. And if they hit the wall right away, you know it, and then you can start to give them a little bit more support to move ahead, but not too long. It's not the whole class by any means.
Great, thank you. And just to clarify, because I see someone is saying that they believe they used the book last semester. This is the new 3rd edition, which just published last week, I think that was. And so if you are using the book now, you probably have the 2nd edition, and the new 3rd edition is thoroughly updated. There's a new chapter on data visualization. There's the new when and why sections that were added to each chapter that Lisa mentioned. So this, you'll want to update to the 3rd edition if you're currently using the 2nd edition. Let's see, we do have more questions. Where do you find the clinical study articles?
So one thing that I use a lot is the Boston Globe, which is our local paper. I'm in Boston. Has this new website called Stat News. So if you go to www.statnews.com, what it is it seems to be a repository where they highlight little snippets of medical studies that come out. And I get the email every morning. I open it up, and it's just a couple of examples of things that are in the news. And for me, it's enough for one slide. It's like those ones that I put up. In fact, I probably got them there when we started. So I would look at Stat News. There's something called Science Daily, all one word, that I look at. And again, that's another one where they just recap current studies. And in these, they'll give a little excerpt. What's really good about some of these also is that the reporter might not always get the technical details right. And so if you find something that's interesting and the students like it, you can often then go search the source article that will refer to it. You can dig that out of the medical literature and then really get into it if you want to do that. So those are two that I use a lot. New England Journal of Medicine, I pull that up a lot, and the Journal of the American Medical Association. You can get right into the current edition, and you can see what what people are publishing. So those are the ones that I tend to use to get examples.
Okay, great. Do you have lab sections in your class?
We do. We just put that in, and we actually found that it was a little bit challenging for students, but just time-wise for the graduate students, we definitely do for the undergrads, but that's where we do more active learning. So if you look in the third edition, another piece that we added was this Framingham data set and the integrative exercises, so more in-depth exercises. Instead of what you see at the end of each chapter are problems, very discrete problems on the topic that we just discussed, whereas these integrative are not tied to any chapter, and so that's where we give students kind of, now try this problem, and they have to piece together, all right, wait a second, is this something that we did this week, or did we do it last week? Bigger picture kind of questions. And so these labs, we do a couple of these each semester where you do much more in-depth, and it's really them doing the work, giving them a big picture problem and just having them go at it either individually or in groups. And I think in groups is much better because of the heterogeneity. There's always somebody who's a little bit more comfortable than somebody else, and they tend to learn from each other.
Great, okay. I think we have a few more questions here. Does your textbook address the ASPPH competencies for biostatistics, and is it apparent in the way the content is presented? I'm not linked to those formally, but yes, we cover all of the things that are there are all the things that I think we would all think would be important in an intro biostatistics class. The ASPPH competencies were guidelines for all of us, and they were related to the accreditation that a lot of us have through the Council on Education for Public Health, but the Council just recently modified its competencies, and they no longer are specific to a particular area, so lots of people are moving away from those. I certainly have learning objectives spelled out for each of the chapters, and those are very much in line with what ASPPH had recommended when they did that project. Great. In your experience, does requiring students to use statistical software to analyze data sets in an introductory biostats course help or hurt?
I think it helps because it makes things more realistic. There's obviously a learning curve. So as I said, we use R, and we chose that because it's free. A lot of our students end up, after they study with us, they'll go do a internship, and it could be anywhere around the world. We just want to make sure they have access to some computing tools if they're doing some analysis. So we use R, and it takes a little bit to get them up to speed, so that's a really good place to use a lab, where you can have students intentionally, maybe not intentionally all the time, make a few mistakes and they can see, all right, you know, the world didn't end by making a few mistakes. They get the hang of it and build up comfort. So I think it's actually helpful just because it gives them a chance to do more realistic things.
Okay, great. Do you cover much in this biostats course about messy data that are not normally distributed besides using chi-squared? I hope I pronounced that right.
Yeah. Yeah. So in public health, we have a lot of applications that have dichotomous outcomes, and so we do talk about in the book. We get to logistic regression analysis. It's, you know, not at a very highly technical level, but get students to hopefully appreciate when you would do a logistic regression analysis and trying to understand the concept of confounding and things like that. We also have a chapter on survival analysis. I would never get to that in a one-semester undergrad course, but we do get to it at the graduate level because we move a little bit more quickly. But those are applications that we definitely do cover because they come up quite frequently in the work that we do.
Great, thank you. How do you explain a confidence interval and p-value in simple terms?
Well, I say a confidence interval is a range of plausible values for some parameter that you're trying to estimate. Nothing that we can do with statistics will let us say definitively we think this value is such and such. So there's always some error built in, and so confidence interval attempts to quantify as best we can some of the error that's in our analysis just by the very nature of doing a statistical study. So it's a range of plausible values based on the data. P-value is the statistical significance, the probability that we observed the data that we observed under the assumptions that were made. I try to be very careful in the language about the p-value because there's a lot of misunderstandings about that, so I actually hesitate to say this because I want to make sure I say it absolutely the way we wrote it down. But, you know, just trying to, in the book when we go through examples, just really try to use the same language over and over again, particularly with things like p-values. So, you know, as I said, probability of observing the data as or more extreme than what we observed under the assumptions that were made. I'm not sure that's the terms.
All right, very good. I have another question here. I have students very interested in biostatistics and may want to pursue an advanced degree, but they're afraid of the math. How can I encourage them to pursue their interest in biostatistics?
Well, programs differ in terms of, you know, how theoretical they are. So we have students here at BU, I can tell you the programs that we offer. We have a number of them that are graduate level in biostatistics. So we have our Masters of Public Health program. So the MPH program has an option to specialize in epidemiology and biostatistics. So if students have a broader interest in public health, but really like the biostat piece, but aren't math majors and really aren't interested in all the, you know, the mathematical and theoretical underpinnings, then an MPH with a focus on biostatistics might be a way to go. People who are more interested in the theory could do an MS, Master of Science in Biostatistics. We have both of those offerings, and then we have a new one that we just mounted this year that's a Master of Science in Applied Biostatistics. It's straddling the fence a little bit. You don't have to be a math major to do this applied biostat, but you do have to have some calculus and have some understanding of matrix algebra, but you don't have to have a full math major. So different schools have different offerings for people with different levels of comfort and interest in the theory.
Great. Okay. Well, I think we're already at 4 minutes past the hour. And we do have, I think I've answered most everyone's questions. I think let's see, it looks like there's 2 more questions here. If we have time, Lisa, if you'd like to answer those 2. Okay, great. Where are the integrated Framingham study problems located? Are they in the book or are they in separate materials online?
They are in separate materials online. So the data set, the documentation, and then this set of exercises are all supplementary materials.
Great. And then last question, you said you use R as a statistical package. Do you have the code you use in labs that go with this text? Is this code available with the text?
We have not made this code available with the text. If this is something that people would be interested in, we could certainly put some of it together for some of the exercises. We provided extensive support really for Excel when we started out in this project. I just threw out that we use R here. If that is something that other people are using, you know, we could certainly explore putting that together. But I'd have to talk to Sophie about that.
Yeah, absolutely. If that's something that can be done, certainly we can explore that and get that out to everyone.
Yeah.
Okay, great. Well, I think we've answered everyone's questions. So before we wrap things up, I just want to mention again that I will make the slides available to everyone in a follow-up email, and I think everyone has probably already received an email with a link to Lisa's to the new 3rd edition of Lisa's book. And again, if you'd like to request a complimentary review copy, you can do that there, as well as access to all the accompanying materials. The entire webinar has been recorded and will be posted on our new Public Health Faculty Lounge group on LinkedIn, which I invite you to join. Well, Lisa, thank you very much for your presentation. That was fantastic.
Thank you.
And thank you to everyone for joining us today.